Okay, good afternoon, everyone, and welcome to this first webinar in a series that the DECT Forum is organizing this year about the new technology DECT NR+. My name is Roel Otting, and I work for the DECT Forum, responsible for business development. And I will be one of the speakers today, but I have two other speakers with me, and I would just hand over to them so they can present themselves. Over to you, Jussi.
Thank you, Roel. So yes, my name is Jussi Numminen. I'm working for Wirepress, and I have some 25 years experience on the standardization, and at the moment I'm a DC DECT Vice Chair.
Thank you, Christian. Over to you.
Hi, my name is Christian Setter. I'm from Nordic Semiconductor, and in Nordic Semiconductor, I am the product director with overall product responsibility for our low power, long range solutions, cellular, and now also DECT NR+.
Okay, thank you both. And the DECT Forum have been giving attention to the new standard and technology DECT NR+ over the past year in different ways. And now that we see that the interest in it is increasing rapidly, we decided that it was time to do a more comprehensive set of webinars to share with everyone out there who is interested all the details of the new standard and the new technology. And today is the first edition. There will be 5 more webinars after this. And on the point of growing interest, we had 434 registrations, which we think is overwhelming, and it's very nice to see. And I can see that already 140 people have joined. So welcome, everyone. Now, just some notes at the beginning of the meeting. The presentation part will take around 30 minutes. After that, of course, it's time for questions. Questions you can send in by pressing the questions button, which should be on the bottom right-hand corner on your screen. And we will answer those questions, or as many as we can, after the presentations. We do intend to cut off after around 45 minutes. And if there are questions left that we haven't yet answered, then of course we will do so after the meeting. The webinar is being recorded and will be made available to everyone who is registered. So what are we covering today? Today we're covering an introduction to the series. We'll take a look at the evolution of the DECT technology over time. We'll take a look at the role of the DECT Forum and ETSI. And then I'll hand over to Jussi and Christian to give an introduction to DECT NR+. And after that, I will be coming back to talk a little bit about the webinars that are coming after this one. Yeah, introduction to the series. So what's the purpose of doing 6 webinars, I would say? So for us, it's important that we provide the full picture, and it all starts with the applications and use cases and customer needs and the problems that customers have and want to get solutions for. So that's why the second webinar in the series will be dedicated to this topic. So we'll talk about all the applications that we can at least in the first instance, address with NR+, including smart grid and smart metering, but also factories and hospitals of the future, and also professional audio. Then the technology, I think Jussi is coming back to that, is agnostic. So essentially, you can do even more things with the technology in the future. Then from the applications, we take a look at, what are these strengths and features and benefits of the NR+ technology, and we make the connection between why NR+ is able to address these applications in such a good way. And then the next step, in the third and fourth webinar, we will go into what we call the technology foundation. So it's one thing saying that we have the best mesh networking solution in the world, but we're also going to show why that is the case, and how the technology works and how the technology actually supports that mesh networking with a high density and a low latency and very high reliability. So at the end of the series, you will have a full understanding from, what can I use the technology for, and what sort of business can I create with it. And you will also understand, how the technology supports that, and right down to the technical detail of it, if you're interested. So I hope that makes sense to you, and I hope that you will find the webinars interesting. Of course, you can always provide feedback, and if you have suggestions as to things that we should be taking up in subsequent webinars, then please feel free to do so. With that, the calendar for this year looks as follows. We have the introduction today. The second webinar, as mentioned, will be about applications and use cases. We plan to do that at the end of May, maybe early June. Date is yet to be set. And of course, you'll be invited. Then after the summer, we will start to look at the technology in 2 different sessions. The first one dealing with the upper layers and the second one with the lower layers. And then in November, we will talk to you about how you can get started with NR+, and hopefully there will be many companies ready to do that. And at this time, we anticipate that development kits will be readily available for people to use. And then in December, we close the series with a recap of the previous ones and also a panel discussion. Right, let's take a look at the DECT technology evolution over time. So the DECT, or the classic DECT technology, as we now refer to it, started to be developed at the end of the 80s and early 90s and was targeted to cordless telephony, both for residential purposes and also for multi-cell enterprise systems. And the first products came to market in the middle of the 90s. Soon after that, it was realized that from the market, there was a requirement for products to be compatible with each other. And a profile was created to ensure that that could be done and tested. It was the DECT Gap profile. The original markets for DECT, as DECT was standardized by ETSI, were the European countries, and the E, in fact, meant European at the beginning and was later changed to enhanced, as the ambition was clearly to go outside Europe and address other parts of the world. And in 2005, there was a decision by the FCC to allocate frequencies in the United States, and that was after several years of hard work from DECT Forum and its members. It was a major breakthrough and, of course, generated a lot of business for our members. And in the meantime, in the European markets, home gateways have made their entry, and operators were offering these for internet access, but they also wanted to have DECT base stations built in. Plus, they wanted to have additional cool features, and they wanted all products to be able to mix and match. So they had to be compatible with each other. That's why a new profile was created, the CAT IQ profile, and DECT Forum provided a certification program, which was very much appreciated by our members, as end customers do find it important to see that their products are certified. And we will certainly aim to create similar programs in the future for DECT NR+. Then we continue to get frequencies in other parts of the world. 2010, Japan allocated frequencies. The technology also kept developing, and a low energy version of DECT was created under the name ULE, and a separate alliance was actually set up for that purpose. Then after feedback from the market about weak security in the standard, that the security was improved, and also for that purpose a certification program was set up by the DECT Forum. Then in more recent days, the classic DECT standard has been improved again, and now with DECT Evolution will even better support professional audio applications. And then we come to DECT NR Plus, and the development of that was started somewhere around 2017 or 18, and the standard is now mature. And we, from the DECT Forum perspective, see this as the start of a new journey, which could very well look like the one we have gone with Classic DECT, and we're very much looking forward to start on that journey with our members and to create that success that we anticipate. And one thing to note at this point, because the radio for this technology is quite different from the Classic DECT radio, but the cornerstones of both technologies are such that they can coexist with each other, and special care is being taken to make sure that that's the case. Then, taking a look at the world map, as you can see, we can call DECT a global technology, and that's a great achievement. At the same time, there are also some major white spots still there, and in particular China and India, who we tried to get access to earlier, but have not yet succeeded. But we do believe that, with the new technology and the applications and the business possibilities that DECT NR Plus offers, that we'll get a new chance to also get access to those markets. Then the companies who started with the DECT technology in the 90s at some stage realized that it was important to have an industry forum, because all the activities were done around the standard in ETSI, but an industry forum was needed for the following purposes. And these are the main activities that DECT Forum engages in. So they're driving the DECT business and the technology roadmap. So in that sense, DECT Forum provides a platform to its members to discuss about business opportunities and trends and market requirements. And there's often competing companies getting together doing these things, but it's for the common good of together creating a standard that makes a lot of sense in terms of creating applications and business. So I think that's the primary most important thing that DECT Forum offers to its members. Then we do more important things. We protect and expand frequencies, as mentioned. We campaign for the DECT technology in different ways. We create and maintain certification programs. And on the other hand, when we have ETSI, and in ETSI, the standards formally, the formal standards are developed, and also technical specifications and things like application profiles to support interoperability, other technical documents, sometimes to communicate outside of ETSI, for example, with regulators, maintaining the relationship with regulators through CEPT. And then also a relationship with ITUR, and it's important to know that ITUR is the organization that has approved DECT NR Plus as a 5G technology, and that was a major milestone reached after a lot of hard work, and Jussi is going to talk more about that in a moment. So DECT Forum and ETSI, we go hand in hand, and we complement each other and work together to get a very good result. Then, maybe a little bit repeating, but anyway, we're starting a new journey with NR Plus, and DECT Forum is very much engaged already and will continue to do things in the area of marketing, webinars, obviously, as you can see, creating collateral in different ways, promoting on social media, presenting at conferences and participating in exhibitions, regulatory work, getting new frequencies and new geographies, or additional frequencies in existing geographies, but also defending the existing frequencies, which happens quite frequently, I would say. And then certification, we are already discussing certification programs for DECT NR Plus, so you can expect those to come. And again, providing members a platform where they can jointly drive the development of the NR Plus business. And I would say, from my perspective at the DECT Forum, we very much welcome companies to join and to start, working on this future together. Yeah, and then before I hand over to Jussi, one last point. What about the name? ETSI refers to the standard is DECT 2020 NR. That's the formal name. But you may also have heard names like DECT 2020 or Private 5G or 5G NR. DECT Forum has decided to market the technology as NR Plus or DECT NR or DECT NR Plus and created this logo for it. So with that, we will try to avoid confusion. This is the name we use. NR refers to the state-of-the-art new radio, and the plus signifies that all the new possibilities that this radio makes possible. Okay, and then I hand over to Jussi.
Thank you, Royal. So yes, so to repeat what Royal a little bit was telling, that the DECT NR Plus is a 5G technology. And basically, I have now copied this famous triangle on the right side of the slide, explaining that what's the IMT 2020 requirement set by the ITU. ITU is an organization of the United Nations which is specialized for the information and communication technologies, and basically this is the organization which is setting the new mobile communication requirements. So basically every 10 years cycle there has been a new requirements for the communication technologies which we have seen in the past 3G, 4G, and now lately 5G. And now the requirements set by the ITU are shown on the triangle, as I said earlier. And for the DECT NR Plus, we are designing that requirement from that angle, that we want to design a system which is addressing for the machine type of communication and ultra and reliable and low latency communication corners of the requirement. And during the rigorous review from the ITU on this IMT 2020 discussions, it was concluded that DECT 2020 is meeting those requirements, and therefore we are part of the 5G technology family in ITU. And the interesting and important point for this one is that we basically are addressing these massive machine type of communication and ultra reliable and low latency requirements with the same this ETSI 103.636 standard series. So you can basically build with this standard both these type of applications if needed. Then a little bit of the DECT NR Plus design objectives for the private networks. So these were principles what we were following and trying to develop the technology so that it could meet these high-level objectives for the use in the future. So the idea is that we have created a wireless communication technology which can be deployed by anyone and operated by anybody and used anywhere. And this is basically now coming from the idea that the traditional communication technologies are usually designed from an angle that there is someone which is managing the system. And we wanted to create a solution which is as autonomous and decentralized that the management of the communication system is basically as minimum as possible. And therefore, the system design is based on the autonomous and device-centric behavior and functionality of the equipments. The second thing what was clear from the beginning is that we need to have a technology which is easy to introduce on the new frequency bands, and this is something that needs to be covered on the standards from the day one. And then the issue what also was bring up by Royal already, that we wanted that this radio is as application agnostic as possible, so that it enables a rapid adoption for different use cases to foster the digitalization. And today I can say that we do not have any application-specific requirements or implementation so far on the standards, but we believe that all those use cases known for us today is possible to address with the current standard set. And the important thing, as mentioning earlier, is that we can focus both the ultra reliable and low latency communication, and machine scale machine communication networks with exploiting the mesh communication. So this is giving a flexibility for the scalability of the use cases, whether they are a bit more wider area local networks or whether they are very dense deployments in some use cases. Then a couple of words about this shared spectrum and especially at the frequency operation. So this DECT band, core band, is definitely of the primary interest for the DECT NR Plus implementations, and this 1.9 gigahertz band is providing a unique spectrum to operate. And here we have designed the DECT NR Plus and the classical DECT so that they can operate together, sharing the spectrum with a minimal interference to each other. And this interference management is possible to optimize to the further extent as we know all the technologies which are operating on this band. And this is actually providing the state-of-art spectrum sharing performance. The other thing which is important on the shared spectrum operation is that we have this autonomous operation and decentralized on that sense that the devices are doing the decisions. So that basically means that they have a local decisions what is the interference and frequency selections to be best to be used for a certain area, and this gives the scaling capabilities for the system, which I'm coming a bit later. This local and optimal spectrum operation is actually minimizing the connectivity management. So on that sense, there is a minimum signaling between the backend systems and the devices itself, and this is enabling a pretty large scale systems for the use. And the standard as of today is supporting multiple TDD bands, both licensed and unlicensed bands from 450 megahertz to 66 gigahertz range. Then a few words about the network topologies, because the system has designed from day one that we can support different type of system deployments in the shared spectrum. So this is something that can be flexibly selected based on the use case and requirements for the operation. So the mesh topology, which is supported as a native for the DECT NR Plus, is providing you a network which basically don't necessarily have a limit in range, and that's coming from the fact that each device which are at the edge of the system is actually extending the range, or in other way they are increasing the communication reliability by offering a different route for the communication. Then the normal start topology, which is very traditional. This is a deployment mode where you can minimize the latency on a single link case, and of course this is viable for the ultra low latency type of use cases on the need basis. And then for the professional audio cases, as an example, the point-to-point connections are still possible with the same technology assets as the other solutions. And basically you can mix and match these topologies, so the system can evolve from the star topology to a mesh topology based on the businesses and the success on that area. Then a few words about the NR Plus scalability. The scalability comes from the angle that firstly we have designed that the system can support up to 4 billion devices in the same network. So this is enabling a pretty large deployments on the marketplace on the need basis. But this large, or let's say huge amount of devices in one single network means that we need to have a very advanced system design in that sense, that how we can control and operate so that the system is reliable. And for this angle also this decentralized operation has been chosen so that the centralized control would not be the blocking factor because that would be causing a increase of traffic for the controlling purposes. So this decentralization and local device level decision is truly enabling a large scale networks on both on the area point of view, but also from the density point of view. And the approach what we have on this wide area operation is basically that we have that achievement by using the mesh topology, and there we are trying to then benefit from the best signal to noise condition connections and utilize the lower possible transmission powers for the reliable communication. So that both means that the interference levels would be lower, as well as the bit rates can be optimized for these use cases. Then a few words about this on the density, which is another demanding topic for the IoT use cases, which we have seen on the marketplace already today. And there are some use cases in industry which is very important that there is a lot of wireless sensors connected in a application where those sensors can be packed in a very small area. So we have seen a use cases where we have more than 1,000 units on a very close proximity, and we still need to have a reliable communication. And this is possible by the local autonomous operation, where the devices can themselves then coordinate how to route and use the frequency spectrum for the best for the application by using the frequency domain, multiple access and TDM at the same time, and utilizing the large power control range what we have in DECT NR+. And again here, the number of the devices in the network can be so high that on this specific case also the central control for the radio resources would be actually not very easy to deploy. Then the last point from my slide is basically the latency. So the physical layer for the NR+ has designed to support the low latency operation. And there is several aspects on this which are supporting this capability. The first one is actually the very fast the mode change between the receiving and transmission mode, so that transition is roughly 40 microseconds, which we are calling a card interval. That is basically how fast the link direction can be changed. But still, the device can have a multiple receiving, and well, that's basically enabling that the devices can have a multiple receiver and transmission events within the one 10 millisecond radio frame, so they can change the direction of the communication multiple times during the radio frame. At the standard level, what is the one direction latency then is that we can meet these 1 millisecond radio layer latencies in a single link, and this is providing a very interesting prospect for the low latency communications, which we have seen already that the professional audio companies are very interested in, and see this is a very important aspect for the applications. And each radio link may operate at the low latency also in a mesh operation, so that we can also on that case minimize the end-to-end latency. Of course, then the overall latency is then the sum of the number of hops what we have, but still we can provide pretty interesting end-to-end latencies for the mesh topologies as well. And with this one, I pass the next slide for Christian.
Yeah, thank you, Jussi. And continuing from Jussi's overview, showing how scalable and capable and non-agnostic to applications this radio standard can be. Also to highlight that if you look at the standard and look at also the definition behind it, it's driven also by companies like Nordic, who have decades of experience designing low power radios. So we have thought very thoroughly around low power as well, and have put in very unique feature set to allow low power, which is so important for machine type and IoT type application. So using very dynamic power control is not only good for scalability and network performance, but by doing that, you can also ensure that you never need to put out more output power than you actually need, and that save power. Also, relay devices, which are devices that typically send communication or relay communication between edge node or child node and back into the sink or gateway. They can manage radio usage within each cluster. It can tell child nodes when the relay device is active and can send data. So this is a network where actually also relay devices can sleep, which is built very deep into the standard itself. And it's also very flexible how relay devices are communicating beacon messaging to child devices and telling them when they need to listen for data. So you can achieve fairly low latencies. You're talking millisecond of latency here, but still allow devices to sleep, which is very unique and save power. But you can also go to lower latency with, let's say, half a minute type of beaconing, which enable you to make very, very low power systems where devices only need to wake up, for example, 2 times every minute, do very low power listening, and then go right back to sleep very, very quick if there's nothing to happen. The other thing that is important to understand initially about the standard when it comes to low power, it is that these features, including routing, retransmissions, a lot of reliability features, is built on lower stack levels of the radio. So if you look at modern radio SoCs today, for example, the ones that Nordic make that have multi-core or multi-domain system, you can enable a lot of this to happen within the radio domain. And you don't need to wake up other cores, other domains, or application domains to ensure that you have a network that are optimized and sending data in either to fix issues or to manage power and things like that. Then talking a little bit about range and reliability of this radio standard as well. So overall, what you should be aware of is that when you look at a lot of the algorithms, a lot of technology that used on the lower layers here, it's using technology and algorithms that is already been used by cellular, so that you already know that there are billions of devices today that operate in the most reliable infrastructure and networks that exist. It can use transmission up to 23 dBm. Even today, doing testing, we achieve more than 3 kilometers of range below actually 23 dBm output power with modulation and signaling that can allow you to send megabits of data over kilometers of range. This also means that you can achieve hundreds of meters of range in very challenging environments, such as urban environment or factory environments, for example, that is very challenging for other radio technologies, typically such as 2.4 gigahertz. And these relay nodes I mentioned, they will scan for interference and find the channel with the least interference. It can update cluster radios on lower part of the stack, and can also instruct children to optimize by changing channels and so forth, so that you can achieve very high reliability and low latency in a system that is still very dense or has very kind of busy in certain channels. An important part of the lower layers that we will talk about later is also this hybrid RQ feature that both enable long range and long reliability, where you have this forward error connection. So when a transmitter is sending data to another device, and if there is failure or issues on this data, the device that received that will still buffer that data and ask for retransmission, so that they can piece together this data very efficiently and very reliable, which is then something that the standard automatically use for all unicast transmission. And then as you're building the network, you can actually decide whether you want to utilize some of these features or not. Because, for example, if you're streaming and doing audio, you don't necessarily want to do error correction at this level, and you can avoid it if you wish to optimize for other things. So with that, I can hand it back to Roel to summarize a little bit and give you a little bit of input on what we're doing next.
Thank you, Christian, and thank you, Jussi, for your introduction to the technology. Yes, so let's take a look at the next webinars. As mentioned, the second one will be about applications, where we're covering smart metering, building management, industrial IoT, professional audio, and PMSC, and also smart hospitals. And again, we will then go into which features and benefits of NR Plus meet the demands in these applications, so you will really understand why this technology is such a strong option for those cases. Then after the summer, we continue with the technology part of the webinars, and the first one is about the upper layers, and we'll see what possibilities the technology provides in creating different types of system topologies and deployments for different types of use cases. We'll explain how the mesh networking works, and also talk about end-to-end protocol functions, link-specific functions, and details on channel access. And then digging down even further into the physical layer, we'll talk about the details of the OFDM parameterization in DECT NR+, and the structure of the physical packets, synchronization and channel estimation, equalization, and more details about channel coding and HARC, and also link performance. So it'll be quite a strong technology drill here. Then webinar 5, again, towards the end of the year, and Nordic will have system in packages and development kits available, and Wirepass software development kits will be available also, and perhaps we can even share some highlights from early customers or trials. And then we'll finish it all off by a recap session and a panel discussion to answer any remaining questions in December. Okay, we're now going to, we're taking a little bit more time for the presentations, and I hope that's fine. We'll have some time for questions anyway, but for those who will leave now, I'd like to say I hope you enjoyed this webinar. Look forward to seeing you again at the next webinars. And again, if you want to be part of shaping the future of the NR+ technology, then you can join the DECT Forum and become a member. If you have any questions about that, then please contact me. Email address is here on this slide. And then we go over to the question part. Okay. So I have a first question here. Will DECT NR+ always be bound to Wirepass, or will it be possible in future to have DECT NR+ without the Wirepass stack, for example, an open source mesh stack? Who can I pass this to? Maybe both of you, Christian and Jussi.
Maybe I start, since the Wirepass was specifically mentioned on the question. Well, the DECT NR+ as an ETSI standard is an open standard which everybody can enjoy and make an implementation on top of that. So definitely there can be another alternative implementation than what Wirepass is doing, and that's the purpose of the public open standard is. And that's also a reason why Royal was bringing up this interoperability and certification efforts what we are building in the DECT Forum, that different implementations and the interoperability can be further tested and make a system out of that. Whether there will be an open source implementations of that one, I rather defer to comment on that one, because that's not in our objectives for time being.
Yeah, I can comment a bit further on what you say, that this is a fully open standard with an open stack specification that anyone can use to create solutions such as Wirepass are now doing and Nordic are working on. So I think anyone who are interested should look into that and assess what and if they want to do something, and they're then up to them to do and realize what they want.
Okay, thank you. We take the next question, which is, can you coexist, or can NR+ coexist with cellular in unlicensed band like CBRS? Who would like to answer that question?
Coexistence on the unlicensed spectrum is based on the regulation and coexistence requirements on that frequency band. Definitely, we can coexist on with the equal terms as the other systems on that band, following the regulation on that one. So it all boils down on the on the Pollard spectrum capabilities of each technologies and how they have been implemented on the system itself. But from day one, this is designed for the shared spectrum operation, as I mentioned, and that applies then, of course, also other technologies.
Okay, thank you, Jussi. We go to the next question. How will units be marketed and presented to make sure that the unit uses the same frequency, since the standard can support 450 megahertz to 6 gigahertz?
Yeah, that's an interesting question, I think. So if you look at radio systems today, typically you will have, component level devices such as what Nordic is making, which will inherently be certified on device or component level to support certain frequencies that support, and then there will be end devices building systems on top of that where they utilize some of these to actually build a product into the market. They will then need to certify those products in terms of radio capabilities in their market and achieve certification according to the radios or the frequencies that they operate in, and are compliant to those frequencies, and then they would then advertise frequency support as part of the network they are deployed in. You can say as a kind of short answer here. I guess we can also mention, and of course this is as a new radio standard, looking at especially certifications and other things. That's still something that we are developing and are being developed, right?
I think one thing to add on this interoperability and the use of the spectrum and different applications. I think one thing, at least what we are interested to maintain, is that there is certainly a certain IoT verticals which are on that sense like a smart meters, that the intention is that it's not necessarily needed for the smart meters, that they can understand what the wireless microphones are doing. So there will be a obvious application verticals which should and could interoperate to each other, but definitely there will be also application areas that is absolutely not needed, and we should not bring such obligations or burdens for the technology implementations to do so.
Thank you, Jussi and Christian. So the next question is, you mentioned audio applications. If the customer needs site-wide communications, do we still need to put a standard DECT system in, or will DECT NR Plus be able to carry DECT communication audio? Okay, so though this is an area that I come from, multi-cell DECT systems for enterprise. I think that's what you were referring to. So DECT NR Plus is capable to carry audio, but it does need to be further developed, I would say, to fit that type of application. So in the first release, you cannot build the same type of multi-cell DECT systems that you can typically buy together with the PBX. So maybe that's a possibility in the future. The technology allows it. I think the market needs to understand the capabilities of creating even better enterprise solutions in the future, because we have a lot more bandwidth to play with, and as mentioned, high density and low latency are also capabilities of this technology. So it is possible in the future to build such systems, but that's not yet going to happen anytime soon, I would say. Then we have the next question. What is the latency in mesh operation? Is it easy to calculate for the number of hops?
Maybe I give a brief answer on that one, that you won't get an accurate numbers on that one, but in principle that is the number of hops. But you need to also take into account that the latency is what are the requirements from the ITU, and what is the performance on those ones as below 1 millisecond. they are layer two latencies of the system. Then on top of that one, on each implementation is the upper layers latencies on the implementations, which needs to be also then taken into account, so that we can actually have a latency of a device which is routing the data. But I'm not expecting that those latencies will be huge, but anyway, there are. So the 1 millisecond as an example is not the whole truth, but you need to also then add the implementation specific latencies of each device.
Yeah, I think you can say that if you wish to optimize for low latency in terms of also how to utilize the radio, then you can achieve something not very far from 1 millisecond between hops, right?
Okay, thank you. I think we have time for one more question, and that's also a technical question. It's, does NR Plus support antenna diversity?
Easy answer is yes. We have a multiple MIMO and beamforming capabilities defined on the physical layer and logical layer. So that's answer is yes. Okay. Thank you very much for your answers in here. And then we've come to the end of this session. I would like to thank everyone again today for joining, and we look forward to seeing you again at the next webinar, end of May, early June. Keep an eye on that. You'll get an invitation. Thanks very much and enjoy your day. Goodbye. Thank you.
Thank you very much. Bye-bye.